Let's see the current divider rule in this video. Now what do I mean? See, when the resistors are connected in parallel, right? So current divides here. Why? Think that current I is entering this junction. At this junction, current has two paths to go. Either it can go through R1 or it can go through what? R2. Now in that case, when current comes here, it divides here. Right? Let's take current through R1 as I1. Current through R2 as what? I2. Now what are the values of I1 and I2 in terms of R1, R2 and I? Let's find it using what? Current divider rule. What do I mean? Let's understand. Now before that, see here, when the resistors are connected in parallel, remember that potential across both R1 and R2 remains what? Same. Why? Look at this here. R1 is connected between what? A and B. R2 is also connected between what? A and B only. So both the resistors are connected between same points here. Right. So when the endpoints of the two resistors are same, potential difference across both of them is also what? Same. So potential difference remains what here? Same. Let's use KCL, and also the concept of potential difference is same, and also Ohm's law to derive the expression for I1 and I2 in terms of I, R1 and R2. Let's find it out here. So first let us apply KCL at the junction what? At this junction A, let us say. KCL at A will apply. Now what happens? What KCL says? The sum of incoming currents is equal to what? Sum of outgoing currents. What is the incoming current at point A? I is incoming here. So I should be equals to what? Outgoing current sum. I1 plus I2 is outgoing. Right. So I should be equals to what? I1 plus I2. Right. Now from this equation, what I can write expression for I2 as? Can I write I2 as plus I1 this side, minus I1. I2 I can write as what? I minus I1. Right, let's call this as equation 1. I am taking plus I1 this side, minus I1. Now what I will do, when the resistors are connected in parallel, as the resistors are connected in parallel, potential difference across both of them remains what? Same. So can I write PD across R1 is same as PD across R2, correct? So PD across R1 is same as what? PD across R2. How can I find potential difference across R1? Can I find using Ohm's law, which is I1 R1 should be same as what? I2 R2. Why potential difference is same? Because both of them are connected in what? Parallel. Now what I will do? I1 R1 I will keep it as it is. What I will do? I2 I will replace with what? I minus I1. I2 I will replace with what? I minus I1 into what? R2. Can I replace? Yes. So I'll write here from what equation? From equation 1. Right. Now what I will do? Multiply this R2 inside. What do you get? I1 R1 equals to what? I into R2 is what? I R2 minus I1 into R2 is what? I1 R2. Now what I will do? I will take this I1 term to the LHS. Now what do I get? See here. I get here I1 R1 as it is minus I1 R2 to the LHS. It becomes what? Plus I1 R2 equals to what? I have here I into R2. Keep that as it is. Or I can write it as R2 into I. I into R2, I am writing it as what? R2 into I. What I can take common in the numerator? Just a second. I think this is I1 R1. Yes. Just a second. Yes, this is I1 R1. I'll just replace this as what? I1 R1. Alright, here you can see this is I1 R1. Now what I can do? I can take I1 common in the new LHS here. If I take I1 common in the LHS, what do I get inside? Inside I get R1 plus R2 equals to what? R2 into I. Correct? Now, what is the expression for I1 now in that case? Take R1 plus R2 to the RHS and divide. What do I get? R2 divided by R1 plus R2 into what? I. So now I got my final expression. Correct. So what is the expression for I1? R2 by R1 plus R2 into what? I. Correct. So I have got, you can see here, observe this equation here. Let's observe this equation and try to write the expression for what? I2 directly here. Right. Look at this here. When I am talking about I1, in the numerator I have here R2. That means I want to find current I1. In the numerator of the RHS, we have resistance of other branch. I want to find current in this branch. In the expression, we have resistance of other branch. Correct? So when I have I1 here, numerator is what? R2. Denominator is what? Sum of the resistances, which is R1 plus what? R2. into what? Total current is I. Similarly, what I can write expression for I2? If I want to find I2, see here, when it is I1, here it is R2. So when it is I2 here it is R1. R1 by what? R1 plus R2 into what? I. I can use this expression to find the currents what? I1 and I2. That's one method. Directly by substituting the values, I can find the values of what? I1 and I2. Or there is one more method which is nothing but ratio method. Right? Using both the methods, let's solve one problem. Let's take a problem here. Yes, here you can see I have just taken one problem here. Resistors are what? 3 ohm and 6 ohm. They are connected in parallel. When the current of 6 amperes enters here, in what ratio currents are divided? Or I want to find the values of what? Basically I1 and I2. Now how can I do this here? Let's understand this. Take that, see here, what is the expression I got in the previous case? I got I1 as what? R2 by R1 plus R2 into what? I. Correct? When it is I1 here it is R2. Remember, R2 value is how much here? 6 ohm. R2 is 6 divided by R1 plus R2 is what? 3 plus 6. Right? 3 plus 6 into total current I is what? 6 here. Correct? 6 6 are 36. Right? 6 6 are 36 divided by 3 plus 6 is what? 9. 36 by 9 is what? 4 ampere. So I got the expression or I got the value of what? I1. I1 is how much here? 4 ampere. See here, I got I1 as what? 4 ampere. You can find the value of I2 using what? Using the expression what? I2 equals to R2 by R1 plus R2 into what? I. Or there is one more method. I will explain that method also. How can I find the value of I2? See here. Just a second. This is not R2. This has to be what? R1. Correct? Because when it is I2, here it is the resistance of other branch. So how much is the value of R1? R1 is how much? 3 ohm. So it is 3 ohm divided by 3 plus 6, 9 into total current is what? 6. 3 6 are 18. 3 plus 6 is 9. 18 by 9 is what? 2 ampere. I got the value of what? I2. I2 is how much here? 2 ampere. I can find this using this formula, or I told there is one more method. What is that one more method? See here, I2 is how much? A current of 6 ampere is entering here, right? In that, I got the value of I1 as how much? 4 ampere. I1 is 4 ampere. I can use simply KCL here. 6 is incoming. Here 4 is outgoing. Out of 6, 4 is going here. Remaining is how much? 6 minus 4. That should go here. 2 ampere current should go here. Correct? Now you can see I found the values of I1 and I2. I found using the formula. I2 is how much here? See here, 6 minus 4 I can find using that. How much you get? 2 ampere. That's one method. Or there is one more method which is nothing but ratio method. If you are good at ratio, use the method I am going to tell you now. Or if you are not good at ratio, if you find it difficult, you can always follow this method. Right. So what is ratio method? Let's understand. What I will do, see here, resistors are in what ratio? Here it is 3 ohm, here it is what? 6 ohm. Resistors are in what ratio? Let's write the ratio of what? R1 and R2. Resistors are in what ratio? 3:6. That is 3 ones are, 3 twos are. Resistors are in the ratio of what? 1:2. Right. Currents should be inverse ratio of resistances. If resistors are in the ratio 1:2, currents should be in the ratio of what? 2:1. What do I mean? You have 6 ampere current. You divide this into what? 2 parts. In which ratio? 2:1 ratio. 6 I want you to divide into 2 parts such that they are in the ratio 2:1. What are the numbers? 4 ampere and what? 2 ampere. You can see the ratio is 2:1. And also you can see 4 plus 2 is what? 6 ampere. So current I1 is what? 4 ampere. Current I2 is what? 2 ampere. This is what ratio method is. If you are finding it difficult to find it using ratio method, you can always follow what? The formula method. Right. That's how we find the currents in what? Different branches using what? Current divider rule.